Hello, everyone. Good afternoon, and welcome to the part two of this amazing series we have started. And big thank you to DDS CAD for doing it for us and sharing their wealth of knowledge with the community, the engineering community, and students here. So special thanks to them, and welcome to everyone. Before we go into the webinar, I just wanted to share a couple of things with all of you on the great work we are doing and what is upcoming. So if we move on to the next slide. So yes, I'll be sharing about the upcoming events we have, and then we'll be introducing our speaker for today, the presenter for today, and of course he will be presenting his bit on the topic, and then there'll be a question answer, and and the meeting will be adjourned. And of course, this meeting is being recorded, which will be shared with the attendees. So moving on, with FES we've had an amazing year so far, and we still have some amazing events to go. And of course, all of this cannot be done without the sponsors. So really want to thank, before we get into anything, we want to thank all our sponsors, our platinum annual sponsors, as you can see here, and then our gold annual sponsors on the next slide, and then also our silver annual sponsors, which will be on our next slide. So special thanks to each one of these companies and individuals for supporting the great work we do and for giving back, for the opportunity to give back to the community. And also special thanks to DDS CAD. They are also not only they're doing this for us, but they're also our silver sponsors and supporting us for many years now. Other than what we do, we also support a lot of activities with our four student chapters, I have to say, because Miami-Dade College, we have a student chapter in the Kendall campus and Wilson, and then we have a UM chapter and a FIU chapter. And for this specific presentation, we have invited all of them to take full advantage of this and learn these skills. So just wanted to give a shout out to all our student chapters. And moving on, our next event which we have coming up is our annual Student Development and Scholarship Golf Tournament, which is one of our very important events, because all the money we raise from this event is what goes towards supporting the scholarships we give. Last year we gave out 5 scholarships, I think each one of them was $3,000, and for high school as well as for university. There were 2 university and 3 high school scholarships we gave out last year, and we would like to do the same, and all that scholarships are supported by this event. So we'll highly like to encourage each one of you, if you have not yet participated in this or not registered for this, if you can, please be a part of this great event. We really have a very good turnout. It's in an amazing place, Grandin Golf in the Key Biscayne, which is an amazing location, and also you are supporting a great cause. So come for this event, enjoy yourself, and also support a great cause. And this is a QR code you can use to sign up for the event. Next, after that, on May 22nd, we do have another webinar in the same series, which you are attending the session 2 for, the session 3, which is about designing a roundabouts and modeling a cul-de-sac in Civil 3D. Again, Doug will be a speaker on that, and which will be on May 22nd, Thursday at 12 noon. So look forward for this one. Once we are done with today's event, we'll be advertising the session 3. So look forward to that. And another great event which we have coming up is, the title is not correct there, but it's WT District 6 work program. We do this every year, and we invite the executive leadership team from the Florida Department of Transportation District 6. So Danny English is the District 6 Secretary, and the District 6 Director of Transportation Operations, Rudy Garcia, will be there. And my understanding is, by the time our presentation comes in, even the Director for Transportation Development, which the position which is vacant now, will be filled in by that, and the person who is appointed on that will be attending this event as well. So we'll look forward for an active participation from the industry on this one. It's a very special event, and this is a QR code which will be on June 10th from 11:30 to 1:30 in the Pullman Airport Hotel. So look forward for all these events. We might have one more coming up, which will be the Miami-Dade County Work Program. We have not finalized the date and the location yet, which will be happening in July, but look out, be on a lookout for that one as well. And without further ado, let me introduce our amazing speaker for this specific webinar, Doug Medley. He is someone who has been doing this for more than 35 years and have been training and conducting trainings with Autodesk products. And he's an Autodesk certified trainer as well, a support professional for 35 plus years, and have been doing this AutoCAD related trainings for many years now. And also, if you know what Florida Design Expo is, which FDOT conducts, and also what FLUG is, Florida Local User Group Workshop, which happen every year, and there is participation from throughout the state, even outside state. People participate in those conferences to get trained on what is happening latest in the CAD. He has been a trainer on those both of these conferences for many years now, and has been training people throughout the state as well as in other states. So without any further ado, let's welcome Doug Medley. Doug, over to you.
Thank you so much. Well, again, I am an infrastructure technical specialist with DDS CAD. So thank you for attending today's FES webinar number 2. And today we're going to be talking about creating intersections in Civil 3D 2025. So in Civil 3D, you can create dynamic models of 3-way T-shaped or 4-way intersections. Now, in the simplest form, an intersection is created by selecting the location where 2 alignments intersect. It creates an intersection object in the drawing, and this intersection object is displayed in the prospector underneath your tool space, in the prospector tab. Now, another approach to creating intersections is to first create your roadway alignments, then your offset alignments, and then the associated profiles. Once these preliminary design items are in place, you can create an intersection object that utilizes the 3D aspects of these roadway design geometry components. Now, intersections are created and are based on existing Autodesk Civil 3D objects, which include your alignments, which is the horizontal piece. That's used by the intersection to define the center lines of the 2 roads that intersects. Now, there are 3 types of alignments that we can use: centerline alignments, offset alignments, and curve return alignments. Okay, the center line and offset alignments are used to define the horizontal geometry of our intersection object. Our profiles, which is our vertical alignments, which are used to define the surface and to define the elevations along the horizontal alignment. Surfaces, which are used to build the surface profiles and then are used for the corridor grading of the intersection. And then corridors, a corridor can be built to represent the 3D aspects of the intersection. Okay, you can either build this corridor as an individual object, or you can add it to an existing corridor that may already exist in your drawing. Now, assemblies, all right? The roadway assemblies are required to build that corridor, okay? Now, you can build the assemblies ahead of time, and you have to build these assemblies based upon parameters that this intersection wizard that we're going to be using today requires, okay? Now, once you have built those assemblies, all right, and applied them to that, you can also save them and build something called an assembly set that you can use those predefined assemblies over and over again in other drawings. Now, both the assembly sets and the assemblies, of course, are made from the sub-assemblies that are part of the Civil 3D application that you would use to put together to basically define the geometry of the corridor section, okay? Now, an intersection objects have their own display styles that control the intersection object marker, the intersection components, such as your offset alignments, your curve return alignments, and the corridors. And they all have their own display styles. And if we all know anything about Civil 3D, everything in Civil 3D has a display style that controls how it looks in the drawing. Now, intersecting alignments collection in the prospector tab, all right? After you create an intersection, basically in the prospector tab, you're going to have a section called intersection alignments, okay? Now you can expand that out and you can see that it's going to tell you what alignments were used to create the intersection. You also can select on an alignment and right click and basically use this command here called explore in prospector. And really what that command is, it's just a shortcut. When you pick it, it just takes you back up to the alignments collection in your Prospector tab underneath your tool space. And then you can go in and make any whatever changes you want to do to that particular alignment. So it's just a tool that helps you sort of go from one place to another, in your Prospector tab in your tool space. Now, once you create an intersection, it's a new Civil 3D object. And it's going to have now in that Prospector tab, there's now going to be an intersection collection. Okay, so that you go to that collection to access the intersection objects in the drawing. As intersection objects are created, they are displayed in the intersection collection. Okay, now when you expand that collection, you can view the names of the intersection objects in the drawing, and then you expand it again, you can display the intersecting alignments collection, or what we call the intersection quadrant collection. Now, either of these collections can be used to display a tabular list of the components in that Prospector list views tree. So if you remember in the Prospector tab, when you pick on something down in the bottom, in that lower left-hand corner, there's that little Prospector list view that will show you different things that are under that particular collection. And that's what we're talking about. Okay, so the Explore and Prospector command is available for centerline alignments, offset alignments, curve return alignments. All right. Now, the intersection collection settings tab. Now we've moved now from the Prospector tab in the tool space to the settings tab. So the intersection collection in the settings tree we use to manage the object settings, which can be the object style, the intersection object styles, the label styles, and the commands that are used to create the intersection. All right. Now an intersection object has its own display style that controls the appearance of the marker. And the components included in the intersection objects, such as the alignments, the profiles, the corridors, and so on, as we all know, have their own display styles as well. Now, an intersection object style controls the intersection object's marker appearance, as I said just a second ago. If you right-click in the intersection collection you can do the following. You can edit the intersection feature settings, or you can edit the intersection label style defaults. And this is very similar how all the other different collections work. You always can get into feature or label style settings. And you can also always refresh the display style. But it's just a new collection that you have in your settings tab. All right. Now, the intersection quadrants collection that you find in the Prospector tab. We use the intersection quadrants collection to access the details about the quadrants that are created when we create the intersections that are contained in the intersection object. So we expand that out to view the names of the quadrants included in the intersection. So if it's a T intersection, it's going to have 2 quadrants. If it's a 4-way intersection, it's going to have 4 quadrants. All right. So this collection displays the names of the curve return alignments in each quadrant. You also can use this collection to display the names of the incoming outgoing lane center lines, again in that Prospector list view. The list view also displays the value of the intersecting angle between the incoming and outgoing lane center lines. Now, when we look in the intersection quadrants collection, and you right-click on that quadrant name, you can edit the curve returns, you can edit the curve return profiles, or you can recreate the corridor regions, or you could refresh the list of things that's in that collection. All right, now, just a couple quick things about deleting intersections, okay? So you can delete an intersection object by erasing it from the drawing, and then it removes it from the intersection collection in the Prospector. When you delete an intersection object in the drawing, the following things are deleted. The intersection object and its label is removed from the drawing. The intersection object and the intersection is removed from the intersection collection in the Prospector. Now, the following components associated with that intersection object are not, now I'll repeat that, are not deleted when you delete the intersection object. The following 2D geometry components associated with the intersection object, which could be the intersection alignments, the offset alignments, and the curve return alignments. All right. The other components associated with the intersection object, the offset profiles, and the curve return profiles. If you create a new corridor object inside that intersection area, when you create that intersection, this corridor object is not deleted when you delete the intersection object from the drawing. You just have to go back and delete the corridor object manually if you want to delete it. You can also use the following methods to delete an intersection object. So in the drawing, you select the intersection object, you can delete it or erase it. If you delete one or both of the intersecting alignments that create the intersection, then that intersection object is automatically deleted. In the drawing, if you move one or both of the intersecting alignments that create the intersection so the alignments no longer exist, then the intersection object is automatically deleted. So these are just things that are very important about when you're working with intersections after you create them. Okay. Now, also deleting intersection object dependent components. What happens when you do those? Centerline profiles. If any of the centerline profiles associated with the intersection are deleted, then the curve returns become static. That means they're no longer dynamic and they won't update if you move things around. Okay? Now, accordingly, the intersection corridors will be updated. Now, the offset alignments. If an offset alignment associated with the intersection object deleted, that offset alignment has a curve return alignment attached to it. The curve return alignment attached to that offset alignment is not deleted. However, the curve return alignment is no longer dynamic to the intersection object. It becomes static, meaning if you make an update or move it, it will not dynamically update. Your assemblies. If any of the assemblies that are used in the intersection are deleted and the corridor is set to rebuild automatic, then the corridor regions that use the deleted assemblies are set to none. And then this creates an empty corridor, even though the corridor regions still exist in the drawing. Then you can go back and use a command called rebuild corridor to download the assemblies or pick the assemblies from the existing drawing and rebuild that corridor region. And we'll go through one of those here in a little bit. All right. So now, creating an intersection. You can create an intersection using this tool called the Create Intersection Wizard. Okay. So before creating an intersection object, you have some things that you have to have. You have to have two alignments that intersect. If you want to create a three-dimensional intersection model, you must also have the profiles associated with the intersecting alignments. Once you have the desired prerequisites, then you can create the intersection using the Create Intersection Wizard. You know how Autodesk is, they love their wizards. Now, to create a simple 2D intersection, when an intersection object is created, a variety of tasks can be performed automatically, including the following. It will create your offset alignments for the roads included in the intersection. It'll create the curve return alignments in the intersection. It'll create the profiles for the offset alignments and the curve return alignments that were created when the intersection was created. Okay. Now, there's a note. An exception to this is that if you set predefined static alignments at offsets, that it's expected you have to specify the profiles. No dynamic offset profiles will be created. So that's kind of a little rule. Or creating a new corridor region from the existing corridor in the intersection area, or creating a new corridor objects in the intersection area. Now, what it does is it locks the profile elevations of the secondary road of the main road, which we call the primary road profile. Now, some of the tasks are optional. They depend on the options that we're going to select in the Create Intersection Wizard. So the simplest way to create a basic two-dimensional object is to start with two alignments that intersect each other only once. You cannot use the Create Intersection Wizard if the alignments do not intersect. If your drawing has two intersecting alignments that meet this criteria, you can then create a basic 2D intersection using the Create Intersection Wizard. You simply start the command and we'll follow the prompts and accept the default choices. And we'll be going through all that in just a few minutes. All right. Now, creating a 3D intersection with corridor objects with alignments and profiles. To create a 3D intersection that includes a corridor, you first need to create your road geometry, your center lines and your alignments, and your profiles, and an existing ground surface in your drawing. Once you have those, you can proceed with the Create Intersection Wizard tool. All right. The wizard prompts you to select the location in the drawing where the two road center lines intersect. Okay. Now, you can start with the following data combinations: two intersecting center line alignments, or two intersecting center alignments with one or more road edge offset alignments, or their profiles. You can have the profiles defined already or not. If the profiles are not available, then the features that are associated with the 3D model will not be available in the wizard. So in other words, if you don't have certain conditions, certain things won't show up in the wizard. Okay. Now, with any of the scenarios we've just described, you can start the Create Intersection command, select the point where the center lines intersect, and then proceed with creating an intersection, using the wizard. Now, when you've got the wizard running, basically the first screen that you come to is going to tell you your road alignments. So it says that if you're creating a T-shaped intersection, which is a three-way, then the alignment that passes through the intersection completely is automatically specified as the primary road. All right. So in this situation, the primary road is going to be set to have a value of 1, and you're not prompted to specify which road is the primary road because it happens automatically. And this becomes important when we get into creating a different type of intersection. Okay. Now, you cannot change the priority of a road of an intersection after it's been created. However, if you want to change the priority of the alignments during the intersection creation, you can do it from the geometry details page. Now, I don't know if I've ever done that before, and I don't think I've ever had anybody call me, but they say that you can do it. It is also important to note that typically the secondary road profile is automatically locked at the intersection location to the elevation of the main road. Okay, so the profile of the main road is not modified. All right, intersection grading options. All right, you have two options in here. So the intersection corridor type property determines the type of grading that will be applied to the intersections. We have two types: primary road crown maintained, or all crowns maintained. And you've got to specify one or the other when you're creating your intersection. Okay, and it's going to be in the general page of the intersection wizard. All right, for an existing intersection, the intersection corridor type is displayed on the intersection details of the intersection properties box. Okay, in the intersection quadrant section. Okay, now once this intersection is created, you cannot change the value of the intersection corridor type. If you want to change this option after you've created the intersection, you've got to delete the intersection object and then create a new one with the desired intersection corridor type. And that's why I went through the deletion part first. Now, this is a little graphic. So in this type of intersection, we're doing a primary crown road maintained. All right. The crown of the primary road is maintained while the crown profile of the secondary road is adjusted to match the edge of the primary road and the intersection point. Okay. The crown profile and edges of the primary road are not affected. When you pick on this, the little graphic in the wizard is going to show like you're seeing right here. All right. Now, a couple things to consider when you create an intersection. It's important to understand the following before you begin creating your first intersection. Use the Create Intersection wizard. You can create an intersection object that contains up to 4 quadrants. If the default intersection assembly mapping and the target assembly does not meet your design requirements, you create an intersection using these components and then edit the intersection regions manually to satisfy your design requirements. Just like creating a corridor model. If you're creating a corridor model, you can go back into the corridor properties and change the values of the different things that you're using. If you create an intersection and then manually edit the intersection corridor regions, the changes will be overwritten if the intersection is regenerated by using the Regenerate Corridor Regions tool or by rebuilding the intersection. That's an important thing. If you make changes and you rebuild it or you recreate it, those changes are going to be lost. And we're going to do an example of that, the last thing we do today. When creating an intersection, targeting both horizontal and vertically is done for you automatically. If you want to change the targets, you must manually modify the intersection corridor regions using the corridor properties dialog box. So typically, after an intersection is creating, the following objects are automatically added to the current drawing: your intersection object, a corridor if you selected it to do that, an assembly, your sub-assemblies, your offset alignments, any curve return alignments. However, the assemblies, the sub-assemblies, the corridors, the profiles are only added if the appropriate options are selected. Now we're talking about assemblies being added. That's if you're using something that we're going to talk about here in a minute called an assembly set. So to create an intersection, we go to the Home tab. All right. Then we go to the Create Design panel and we pick on intersections and we pick on Create Intersection. All right. The first thing it's going to do is it's going to ask you to select a point where the intersection happens. Okay. Now, if you wish to create a throughway intersection, it's important that the alignments meet precisely. Do not underlap, they do not underlap, and they don't overshoot. If the two alignments overlap, then it's by default going to create a four-way intersection. If you're creating a four-way intersection, you're going to be prompted to select the alignment that's going to be defined as a primary road, and you just pick it in the drawing. Okay. If you're creating a T-shaped, then the alignment that passes through that intersection is automatically specified as the primary road. Now, when we get in the wizard, on the general page of the wizard, all right, you can enter a name for the intersection object, or you accept the default. You can also change, add a description, or you can change the defaults for the marker style, the layer, and the labels. All right. Now, for the intersection corridor type, you've got to select either primary crown road maintained or all crowns maintained. Okay. Then you also have some other things that you can do in there. All right. You can basically tell it to create or not to create offset or curve returns. All right. And you can then also go in and change the parameters for your offset alignments, your curve returns, your lane slopes, and your curve return profiles. And we're going to do all this in just a couple minutes. All right. Then you hit next, And now it goes over here, and basically, if you, by default, the new offset alignments are going to be created. Okay, so we click next to proceed to the next page in the wizard. Right, then we get to the page that says, how do you want to create this intersection? Do you want to create a new corridor in the intersection area? If you do, you have to check a box to do that. If you do that, it's going to ask you, do you want to create a new corridor, or do you want to add it to an existing corridor? And then it's going to ask you to the surface to daylight, because remember, that's one of the requirements we have to use the intersection wizard. Then we're going to select an assembly to import. And that could be an assembly that's already existing in the drawing, okay? Or we can select an assembly set to import. And we'll do all this in just a couple of minutes. All right. Once you've answered all these properties, got everything applied correctly, you hit create the intersection, and your intersection is now created. So we're going to start out here by creating something called a pier to the road intersection. Okay. So to create, we're going to create a 3 intersection and generate a corridor that maintains the crowns of both roads. So to create a complete intersection model, we have to have a center line alignment and a profile for each of the intersecting roads. Both the horizontal and vertical geometry for the remaining elements, including the offsets and the curve returns, are going to be generated by the parameters that we're going to specify. So in a pier road intersection, all the crowns of all the intersecting roads are held at a common grade. The pavement for both roads is blended into the curb return region, which forms the transitions between the intersecting roads. So the drawing that we're going to work with in here contains a corridor along each of the intersecting roads. Each corridor is made up of a corridor assembly and a corridor center line. Now, at the end of this example, we're going to have created a new intersection object. We're going to create 2 curb return alignments in their profiles, 4 offset alignments in their profiles, several new corridor regions, and some corridor assemblies for each of the region of that intersection. So let's jump over to Civil 3D. So here's our first example. Well, that was all right. Now, first off, I'm going to go over here in my Prospector tab, my tool space, and I'm going to expand out my alignment, and you're going to see that I have 2 alignments. So I'm going to select on First Street, and I'm going to say select. So this area over here is for my First Street alignment. All right. I'm going to select my Second Street alignment. There's my Second Street alignment. Now, if I expand out First Street, you'll see that I have my design profiles created, and the same thing for Second Street. I should have my design profiles. So that means I've got some of the conditions met. I've got my alignments and I've got my profiles. Okay. Now, if I slide down in here and I look under my corridors, you'll see that I have 2 corridors, First Street and Second Street. So I pick on my First Street corridor and hit select. You'll see that there's my First Street corridor. If I go down here and pick on Second Street, you'll see that here's where my Second Street corridor is located. All right. So I have some existing corridors in the drawing. And if I go up here and I look at my surface, you'll see that I have a surface in the drawing. And it's currently not displayed, but I do have a surface available. Now, if I pan over, you'll see that I have some assemblies that have already been built in the drawing. And I can elect to use those or not to use them. And each one of these assemblies is going to match a condition that's required by the intersection wizard. Okay. And then you'll see that I have 2 profile views with, again, my associated profiles. Now, I'm going to zoom in here. Now, here's a little tip about when you're working with the intersection wizard. The intersection wizard can be a little finicky sometimes. And sometimes when you go to select where your intersection is going to be, it can't find that intersection. And so what I tell people to start out with is go down to their status bar and make sure that you don't have your running OSNAP turned on. And I'm going to turn, for this example, my dynamic input. Now, what I'm going to do is I'm going to select on these 2 alignments. Okay, and I'm going to right click and I'm going to pick on the display order and I'm going to bring them to the front, bring them all to the top of the display list, and that just helps the intersection wizard select that intersection. Okay, so let's get started. Home tab, create design, intersection, create an intersection. And you notice now that even though I had my running OSNAP turned off, the software turns on my intersection snap, and I'm going to zoom in and pull right into here, find that intersection. And if it finds the intersection, when I pick with my left mouse button, it will bring up the create intersection dialog box, which again is made up of general, geometry, pages, and corridor regions. Okay, so to start out, the intersection name, we're going to use the default parameters. So it's going to be called, in our case, primary alignment name, secondary alignment names. My primary alignment was going to be, because it went this alignment went all the way through the intersection, so it's going to be 2nd Street dash 1st Street. And I'm going to leave my intersection marker, layer, and label style as the defaults. And my intersection corridor type, you can see right now it's set at primary road crown maintained. And you see the graphic. I'm going to change that to all crowns maintained. Okay, you see the graphics change. I'm going to hit next. All right, now you'll see up here at the top, it tells me the priorities of the 2 alignments. Okay, now offsetting curve returns and offset curve return profiles. I want to have these 3 boxes checked so it creates and allows me to specify my offset alignments. It creates my curve return alignments, and it creates my offsetting curve return profiles. So we're going to start out by going to the offset parameters first. All right, so for this example, our primary road, all right, when I select, it's highlighted, and so the offset value is 3.5 meters for both the left and the right side. And this data set is a metric data set that I'm using today. Okay, so what I'm going to do is I'm going to change the offset value for my secondary roads. So I'm going to change the offset value for the left side to 3.5, and I'm going to change the offset value for the right side. And as you notice, as I check in the box, my graphic changes to show me what side of the road that I'm working on. Okay, so I've set my offset value for my offset this is going to create. So I'm going to hit OK. Now I'm going to go to my curve return parameters. Okay, now in this example, because it's a T intersection, I'm going to have 2 quadrants, my northwestern quadrant, and I'm going to have my southwestern quadrant. So what I'm going to do is I'm going to change the radius for my northeastern quadrant to 7.5. Okay, now I could hit next and go down here and change that value again. But here's a little tip. I'm going to go back to previous, and I'm going to select on the curve return parameters. And just like any good command in Civil 3D, and everybody that I teach learns this one phrase: when in doubt, right click. So I'm going to right click, and I'm going to say copy these to all quadrants. So that value is now copied to the southeastern quadrant. Right. So that's all I'm going to do. I'm just going to change the radius for those 2 quadrants. Okay. All right, now I'm going to go down and look at my lane slope parameters. So for both the primary road and the secondary road, I'm just going to do a crossfall across the center line of minus 2%. I'm going to leave the defaults. Okay, and then for my curve return profiles parameters, when I look at that, I'm going to leave the defaults. But what we're really looking at right here is that we've got a length to extend along the incoming lane. So my incoming lane, all right, coming in is going to be this area right here. It's going to be 10 meters, and my length to extend my outgoing lane, my default is set at 10 meters. Okay, for both quadrants. So I'm going to set that as okay. All right, now I'm going to hit next. All right, so now this brings us to where things happen. So first off, all right, in the corridor regions page, create corridors in the intersection area. All right, now my option is, do I want to create a corridor? If I uncheck that, it's going to create the intersection and the intersection object, but it's not going to create a corridor. For this example, I want to create a corridor, but I want to add it to an existing corridor. So I'm going to change to add to existing corridor. Now, I can pick from the list, all right, or I can pick the graphic, this little icon right here. When I do that, I'm just going to go over and pick on that 2nd Street corridor, and that'll select it as my corridor. So either I can pick it from the list or I can pick it from the screen. Because my surface isn't displayed, I have to pick it from the list. Now, down here under the corridor region type, all right, so basically you've got different parameters that have to be. Your corridor, your curve return fillets, your primary road section. As I move through, you see the graphics that changes to tell me what we've got. Daylight right, all right, full section for the secondary road, full section daylight right. And over here on this side, these are the assemblies. Now, right now in this drawing, I have some assemblies. So if I pick on the little box here under the curve return fillets, or fillets, I pick here, and I pick the down arrow, I can pick from any assembly that I have in the drawing already, all right? But now for this example, I don't want to do that. I want to load up an assembly set, all right? So I go over here and I pick Browse. Now I'm going to go over here and find an assembly set that I want to use. And the assembly set that I want to use is called Intersection Assembly Set All Crowns. Now this assembly set was created from a drawing. Somebody created the assemblies, and then when they were in this box, they picked on the option Save as a Save Set. and they saved it away, and it creates this XML file. Now, when I loaded it in, what you're seeing here now is it basically has applied those assemblies in the proper locations in the list. Okay, so once I've got these things in, I have no more gray buttons, and I'm going to create my intersection. And now you've created your first intersection. So if I zoom in, you'll see here that I have an intersection marker. If I pick on it, you'll see up here in the ribbon, I get a context-sensitive tab that says intersection, Second Street, First Street, and you'll see that here's all the things that I can go in and I can edit, in that intersection. Okay, I'm gonna hit escape to release it. Now, I'm gonna go out here and I'm gonna take a quick look to see what's been created. So under my alignments now, I now have some offset alignments that it created automatically. So I've got my First Street left, First Street right, and if I expand those out, you'll see that it created the profile for me. Okay. If I go down here, I see it now created my curve returns for Second Streets. If I expand those out, you'll see that it's created the profiles for me for both of those. If I slide down in my prospector, you'll see that my corridor is still there, but now, because I didn't create a new corridor, I added this intersection as a corridor to Second Street. All right, if I go down here, now I've got my intersection. If I expand out my intersection alignments, right, you'll see now that there's my Second Street. So there's my it tells me the alignments was used for my intersection at Second Street, First and Second Street, and then it tells me my quadrants that were created, the northeast and the southeast. And here's that little trick that they showed you. If I under intersecting alignments, if I right click and then I say explore and prospector, it pops me back up in my list. All right, and it takes me right to takes me right to the alignment that I want to work with. Okay, so Second Street, right click, explore and prospector, and it took me right up in my prospector. It took me right to the alignment. Okay, so there you go. So that's what's created when you create an intersection object. Now we've got a little cleanup work to do. Now, one of the things that we have this gap right here. So I'm going to select on this corridor model, and I'm going to select on this script. Now, in order for this to work, I have to have dynamic input turned on. So if I zoom in, you'll see I'm around 0 plus 040, going down to 0 plus 020. I'm going to take my cursor and I'm going to move it down, and I'm going to type in 21. And when I hit enter, it's going to move that marker down to station 21. Now, nothing happens. It's not very impressive. It's because the corridor is set up not to automatically rebuild. We'll fix that in a second. All right, let's move down here. Let's do it a different way. Now, you'll notice that when I have the corridor selected in my ribbon, it's got an intersection tab, all right? It'd be working on the actual intersection components, or I go to the corridor and I'm looking at the things that make up the corridor. Now, what I'm going to do is I'm going to go to the corridor Second Street tab, modify region, copy region, and I'm going to select right down here in this region right here. All right, now I'm presented with some options at my command line. Fill or baseline. I want to use the fill option, so I can either type in the letter F and hit enter, pick on the word fill at the command line, or when in doubt, right click and pick fill. Now what it says is when I move my cursor into that gap, it's going to present me with this red line. It says, this is the area that I'm going to fill. Is this what you want? Yes, it is. And I'm going to pick. And there we go. So it filled the gap. But now if I zoom out, I've still got this problem. This has not been filled in. Well, with the corridor still selected, and I'm still in the corridor Second Street tab, I go over here to modify corridor, rebuild corridor, and pick rebuild corridor, and it automatically rebuilds that region in places in where I told it to extend it when I moved that marker. Okay. All right, let me hit escape. Let me zoom into here. I'm going to grab on the First Street corridor. I'm going to grab this marker, and I'm going to zoom in, and my running O-snap is still not set. So I'm going to do a shift right click to do a running O-snap, pick intersection, and I'm going to snap right on this intersection right here. And now I have drugged that region down and filled in the gap. So there you go. So that's how you would build a pier road intersection. All right. Now let's move over to creating a primary road with turn lanes. So one of the things that we can do with this intersection tool is we can create intersections with turn lanes. All right, so let's go back to the drawing. right? So in this drawing here, we've got 4 alignments, and all of them have profiles, because you can see the profiles. But in this drawing, there are no assemblies. You'll see if we slide down here in our prospect here, right, that there are no assemblies, right? And there is no intersection, and there are no corridors, okay? So what we're going to do is we're going to zoom in on this area here. And again, I'm going to do that same little trick. I'm going to select the alignment. I'm going to right click, display order, bring to front, okay? All right, so home tab, create design, okay? So again, we're creating a primary road intersection with turn lanes. So we go create design, intersection, create intersection, okay? I'm going to select my intersection point, right? Now it asks me to select the main road alignment. Now I either can pick it graphically on the screen, or I can pick it by selecting from the screen, which is what I'm going to do. Right? And now my wizard starts up. Now you notice the intersection name has changed. Now it's just an intersection, and it's just using a default counter. So whatever the next free counter is, whether it's 1, 2, or 3, that's what it's going to call it. I'm not going to change any of the marker styles, but I am going to make sure that my intersection corridor type is primary road crown maintained. I'm going to hit next. Okay. Again, offset and curb returns, offset and curb return profiles. I want to make sure that all these things are selected and turned on. So I'm going to start out by setting my offset parameters. All right, so what I'm going to start out with first here is I'm going to change my primary road left and right alignments values from 3 meters to 6 meters. Okay, that's all I'm going to change. Okay, then I'm going to go down to my curb return profile. Now, I've got 4 quadrants that I'm working with, and I'll just pick my little list so you can see 4 quadrants. So I'm going to start out in the northeast quadrant. Now I'm going to leave the radius set at 10 for this example. Okay. Now we're going to add a widening for a turn lane on all 4 of these conditions in these quadrants. So for northeastern quadrant, I'm going to do an in for an outgoing. Okay. So the outgoing being the turn lane is going to be here. Okay, so an outgoing lane. So I'm going to hit next. All right, for the southeastern quadrant, I'm going to do an incoming. Hit next. For the southwestern quadrant, I'm going to do an outgoing. Hit next. And then for the northwestern quadrant, I'm going to do an incoming. All right, I'm going to hit OK. All right, now I'm going to leave all the values for the lane slope parameters, the curb return parameters set at the defaults. So I'm going to hit next. Okay. Now, because I don't have a corridor in there, I have to create a new corridor. I'm going to make sure I've got my target, my existing ground. Now, for this example, I'm going to use an assembly set because there are no assemblies in this drawing. So I'm going to go to Browse. And this time, I'm going to pick an assembly set that comes with Civil 3D out of the box. So I'm going to go down to the folder called Program Data. So on your C drive, there's a folder called Program Data. You go to Autodesk. You go down and you pick on Civil 3D 2025. You go and you pick on E&U. You pick on assemblies, and they give you 2 different assembly groupings, one for period and imperial units, the other one for metric units. I'm going to go to metric, and I'm going to pick on the underscore Autodesk metric assembly sets, and I'm going to pick open. Okay. And again, it just applies the assemblies to the proper conditions. Okay, and I'm going to hit create an intersection. Okay, so there you go. Now, I want you to notice here that the intersection, the offset alignments only extend to the end of the condition of where this intersection is being created. Now, if I want these offset alignments to extend all the way to the beginning and the end of the alignment, when I was creating it, there was a box I could have picked to have it create the offset alignment from the start of the alignment to the end of the alignment. Okay, so what I'm going to do is going to show you how you could fix that. If I pick it, all right, and I go up here to alignment properties, and I go over here to the offset parameters and the starting station. I'm just going to tell it to pick at the starting station, do the defaults, and hit OK. What it do now is that alignment now is going to go all the way, start at the beginning and go to the end. And I'm going to do the same thing for this alignment right here. So I'm going to select it, all right, alignment properties, design criteria, sorry, wrong thing. Select it, alignment properties. Pick the wrong alignment. I need the offset alignment, not the actual alignment. All right, check it, hit OK. And now we'll see now that that alignment starts, all right, and it ends, all right. So that's how you can fix a mistake. So if you had meant to have done that when you were in the intersection wizard, that's how you can repair that problem. Okay, so there we go. So there's how we created an intersection. Okay, and again, the same things happen. We go over here, it's created the offset alignments, and it's created your curve return alignments. Okay, and it's created the new corridor, and it's gone down here, and it's created your new intersection. Okay. And if I right click here and I say rebuild, update, rebuild the corridor, it's going to update the intersection, and it's going to go up here, and you'll notice now the corridor is also updated as well. So everything's good to go. Okay. All right. Create an intersection with existing geometry. All right. So in this intersection exercise, we're going to use the existing offsets that we just created and the profiles of the roads to create the intersection and add the new intersection to an existing corridor that we have in here. So the workflow in this demonstration, this exercise, is useful when you need to create several intersections along a single corridor. You define the offset geometry for the primary road, and then you can just reuse it for any more additional intersections that you may need to create. All right, so let's go over here. So now you'll notice that in this particular drawing, right, you can see now how we have our offset alignments. They're going from start to end, and basically it's the same intersection that we just did. So we're going to be working down here on this intersection down here. All right. So in this example, I'm not going to pull these to the front, and let's see what happens. All right, give me just a second here. All right, so we're going to be creating an intersection with existing geometry. All right, so same thing, home tab, create design, intersection, create an intersection. Okay, we're going to select the intersection point. Because it's a four-way intersection, it's going to ask me to select the alignment. I'm going to pick on this alignment right here. Okay, when it comes up, I'm going to leave the defaults. All right, primary road crown maintain is what I want to use. I'm going to pick next. All right, now my offset parameters. All right, I'm going to select it, but this time I'm not going to create new offsets. I'm going to use the existing information. So for the primary road, I'm going to, where it says use the existing alignment, I'm going to say yes. And then I'm going to pick under the alignment name, the ellipse box, and I'm going to pick on the graphic so I can select it from the screen. And I'm going to pick this alignment right here. And I'm going to hit OK. And I'm going to repeat that for the right side. Okay, pick it again. Pick the box. And I'm going to say right here. That looks good, right? So I'm going to hit OK. Now I've got to go down here and I've got to set my parameters up here for my vertical part of that. All right, so for my curve return parameters, all right. Let's see. All right. I'm going to be working with two quadrants. I'm going to be working with the southwestern quadrant, okay? And on the southwestern quadrant, I'm going to be doing a incoming road, a widening for an incoming road. And then I'm going to move over here to my northwestern quadrant, and I'm going to do the same thing for an incoming road, okay? All right, now I'm going to go down here to my lane slope parameters, okay? Now this is where I'm going to use the profiles that the software created previously for these two offsets. All right, so I'm going to change it to yes, and I'm going to say profile name. Now, I'm going to go down here and look under road A, and I'm going to say road A minus 2%. That'd be for my left side. And then for my right side, I'm going to say yes, and I'm going to say the profile name, road A minus 2%, left paren 1, right paren. And it's just the way the software names it. So what I would recommend is if you create these things and you know you're going to use them over it, go in to your prospector tab and under those profiles and give them a name that you can recognize what they are. Okay. All right, I'm going to hit OK. Right? So everything looks good. Curvature and parameters will leave the way they are. We're going to hit next. Right? Now, we're going to add this to an existing corridor. Right? And we only have one corridor in the drawing, corridor 1, existing ground. We're going to go to browse. We're going to use the same assembly that we used previously, this metric assembly. Okay, so it adds everything to the list properly. And I'm going to say create the intersection. And so there you go. So now here's your incoming turn lane here in this quadrant, and here's your incoming turn lane in this quadrant. Right. Well, we go back here and we look now underneath our alignments. You'll see that we've got our offset alignments in here, and we've got our curvature alignments. If we slide down the list, you'll see that we've got our intersection in here. All right. And if we looked here, you'll see that it's brought in all those assemblies, all right, from that XML file. Now, I'm going to select on this corridor here, okay? And I'm going to go up here and do that copy region trick again. So it's modify region, copy region. I'm going to pick here. I'm going to right click and say fill. And I'm going to pick, and I've filled in the region. So there we go. So now we've created a new corridor using existing geometry, which in this case was those 2 offset alignments and the 2 profiles that were created for those offset alignments. Okay, the last thing that we're going to do here is creating and editing a corridor in the intersection area. Okay, so in this exercise, we're going to create a corridor using existing vertical and horizontal geometry. And then we're going to modify the corridor in the intersection area and experiment with this corridor recreation tools. All right, so what we're going to do here is, that we're going to zoom in, and you can see that they have created an intersection without creating a corridor. So they didn't check that box in the wizard. So if I pick on that marker, you can see these are all the things that I can do. If I go over here and I look, all right, under my alignments, you'll see that I've got my center line alignments, I've got my offset alignments, I've got my curvature alignments, because even though it didn't create the corridor, it created all that information and it created the profiles, the required profiles. Okay. Also in here, all right, you'll see that we have no corridors right now because it was never created in this file. So what we're going to do here with intersection marker created, looking at the intersection 1 tab, we're going to go over to the modified panel. We're going to pick on recreate corridor region. Okay, and so we're going to create a new corridor, and we have to tell it the surface to daylight to. All right, and I'm going to pick the assembly set that I want to use. All right, and I'm going to use that metric assembly set again, and I'm going to hit open. Okay, and now I'm going to go here and pick recreate. Now, if in this file I had assemblies that I wanted to do, I could add those by picking in the ellipse box and adding them in there. And then when I was done, I could pick save as a set, and that would create a new assembly set. So I'm going to pick recreate. And now it's created that intersection for us based upon the parameters that we specified. Okay. Now I'm going to very quickly grab this right here, and I'm going to extend down this down to around 220. Okay. And now the first thing I notice that in my regions there, my tangent spacing is wrong. I want it to be bigger. So I'm going to hit escape. I'm going to select the corridor. I'm going to go up here to corridor properties. Okay. Under the corridor tab, and under the parameters tab, I'm going to select that region from the drawing, and I'm going to select it. And what I'm going to do is I'm going to modify the frequencies. All right, so I'm going to change along the tangents, I'm going to set that to 10, and along the curves can be set at an increment. All right, the curve, I'm going to set that at 5. Along spirals, and as you all know, when you're creating corridors, typically you set your curves and your spirals half of whatever your tangents are. And then for along my vertical curves, I'm going to set that at 5. Okay, and now I'm going to hit OK, and I'm going to start to rebuild the corridor to apply those changes. So you can see now that my regions have been spaced out for my tangents, and then if I pan up, you'll see that now my spacing for my curves is going to be set at about 5 feet. Now, you notice down here in my Prospector tab, my intersection is now saying it's out of date. If I right click on it and I say update region and rebuild corridor, I'm going to lose all my changes. Or if I pick recreate corridor regions, I'm going to lose all my changes. All right. Now, with my corridor still highlighted, all right, and I pick on the there's a couple different ways to do it. I'm thinking here what's going to be probably the fastest way to do it here. Let's just go up here and pick on under the intersections. All right, and I'm just going to pick recreate corridor regions. Okay, and that's the same as picking it from over there. Right, pick recreate corridor regions. Right, and I'm just going to make sure that I have the right assembly set. I'm going to hit open. All right, and I'm going to pick recreate. And you'll notice that what happened is all of a sudden everything disappears, everything goes back to the way it was. And the reason is that because the corridor was recreated using the parameters that were originally specified during the intersection creation process. So remember, any modifications that are made to the corridor in the intersection area are not retained when you recreate the corridor from an intersection object. Okay, so there we go. So those were the 4 examples that I wanted to show you. So, Sandra, any questions?
I know, it seems like you were very clear. So I guess it was a lot of information, but I think you covered a lot, but it was very clear. And hopefully if they have any further questions, they can always write to us at info@dbscat, and we'll be happy to have you answer any questions they might have. So you can go to the next slide if that's okay. Thank you everybody for attending the webinar today. Thank you, TEG and FES for allowing us to be part of this webinar series. And we're having a third one coming up. So please make sure on May 22nd, make sure you join us for the last one. And thanks again for your time today, for being here. I think there's one more slide after or before. Yes, so any questions, please feel free to reach out to us at Digital Drafting Systems. And we're looking forward to seeing you May 22nd again. Thanks, Doug, for a great presentation. And thanks, FES, for allowing us to reach out to you and provide this educational series. Thank you. Have a good day.
Thanks, everyone.
Okay.